So once again, you're welcome back to today's episode of our online lesson. And in our previous lesson yesterday, we're looking at modular arithmetic, for which I left one question with you. And it says, if the time now is 5 a.m., what will be the time in 22 hours? What will be the time in 22 hours? Now, Robert, you gave me the right answer, and I'm so grateful for that. You said the answer was actually 3 o'clock a.m. 3 o'clock a.m. and for which I will say it is right. Now, we have 24 hours clock, and then we also have the 12-hour shift kind of thing. Now, you can choose to use any of them. If we consider, let's say, 5 a.m., 24 hours time, it's actually also going to be 5 a.m. I hope you agree with me. 24 hours time, 5 a.m. right now, 24 hours time is still going to be 5 a.m. I hope you are with me.
Yes, sir.
So logically, if I'm not going for 24 hours and I'm talking about just 22 hours, then it means that we are 2 hours short of 24 hours. Hence, 2 hours away from 5 a.m. will automatically be 3 a.m. Do you agree with that?
Yes, please.
Yes, so that is why the answer is actually 3 a.m. 22 mod 12, what will you get?
10 mod 12.
So you have 10 mod 12. So getting 10 mod 12, then in this case, your 5 a.m., if you even label it 5 a.m., sorry, 10, 11, 12 p.m., this is 12 a.m. Then you have 1 a.m., 2 a.m., and then 3 a.m. So when you count, remember the 5 a.m. is where we are starting from. So you are actually going to have 1, 2, 3, 4, 5. Remember what I'm writing up here is the hours. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. So 22 hours will automatically fall on the time 3 a.m. 22 hours will automatically fall on the time 3 a.m. because the first 12 hours will represent 1/2 of the day. Then the extra 10 hours will give you the next part of the day. Please, are you with me?
Sir.
Okay, good. So that is the way you can actually solve. If the time now is 5 a.m., what will be the time in 22 hours? What will be the time in 22 hours? So we are moving on to our next idea for today. Now, in today's lesson, we are actually going to look at what we call tables in modular arithmetic. Tables in modular arithmetic. That's what we want to look at today. Tables in modular arithmetic. Now, when we consider tables in modular arithmetic, there are two main tables we are going to use. We have what we call the addition table, and then we have the multiplication table. Now, when we get this concept very fast, then I can move on to another thing today within the same period. So when we talk about the addition table, the symbol we use to represent the addition table is a plus with a circle around it. Then multiplication table is a times with a circle around it. Remember, whenever you are adding, you can add 2 or more entries. When you are multiplying, you can multiply 2 or more entries, but we always start with 2 entries at a time. We always start with 2 entries at a time. So you may be asked to actually write down the addition table in mode 5. Let's start with mode 5. So in mode 5, what are the elements that we can use in adding up in mode 5? Yes, what are they? what elements or entries can we use in mode 5? It involves
0,
yes,
1, 2, 3, and 4.
thank you. So these are the entries we can use in mode 5. We cannot use any other number, but these are the major entries you can use in mode 5. And therefore, addition table in mode 5, then you can draw your table. Please, you don't have to waste time on this whenever you are drawing. You can actually write the numbers before you put on the lines. So you have your addition here, then you have your 0, 1, 2, 3, and then 4. 0, 1, 2, 3, and then 4. Then now you introduce the other columns and then the rows. You don't have to waste time on this at all. You don't need to. And it will be advisable to use a pencil so that whenever you make any error, you can erase easily. So that is what we have here. So remember that we said that modular arithmetic, another name we give to modular arithmetic is what?
Remainder.
Remainder arithmetic. Good. So whatever addition we are going to operate on, we need only the remainders. Remember, we are in mode 5. So this is addition table in mode 5. Addition table in mode 5. So we have 0 plus 0. The answer is still 0. 0 plus 1, we have 1. 0 plus 2, we have 2. 0 plus 3, 3. 0 plus 4, 4. All the values we are having, they are less than the mode. So in other words, we put them there. Now 1 plus 0, we have 1. 1 plus 1, we have 2. 1 plus 2, we have 3. 1 plus 3, we have 4. But 1 plus 4, the answer is 5. So you ask yourself, 5 in mode 5, what's the answer? It's 0. So it means the cycle begins again. Then we have 2 plus 0, the answer is 2. 2 plus 1, the answer is 3. 2 plus 2, the answer is actually 4. But 2 plus 3, we have the answer as 5. And if it is 5, 5 in mode 5, what do we expect? Yes, what do we expect?
0.
We expect 0. 2 plus 4, the answer is 6. We can put 6 down. So 6 in mode 5, what is the answer?
1.
That is 1.
1.
So the cycle begins again. The cycle begins again. Then moving on, we have here 3 plus 0, which is 3. 3 plus 1, which is 4. 3 plus 2, 5. 3 plus 3, sorry.
Yeah.
So that is 0. Thank you.
Okay.
So we have 0. 3 plus 3 is 6, which is 1 in mode 5. 3 plus 4, the answer is 7, which is what? 2 in mode 5. So the cycle also begins again. So actually you have 4 here, 0, 1, 2, and 3. And this kind of operation, you realize that all the answers we are obtaining, they are exactly part of the entries for mode 4. They are the entries for mode 5, sorry. They are the same entries for mode 5. Hence, we say that the set is closed because we are not getting any other entry apart from all the entries you are having in mode 5. So we will say that the set is actually closed. So ideally, this is what we expect for addition table in mode 5. Addition table in mode 5. Any question on that? Then I'll go to multiplication table in mode 5. I believe it's very easy. Okay, so let's go to multiplication table in mode 5. So that one too, you have our table drawn. Yeah, I know I can finish this within the shortest possible time. Then I'll move on to another thing. So we have multiplication sign there. We have a 0, 1, 2, 3, and 4. So 0, 1, 2, 3, and 4. Now today, what we are looking at, we are just using all the entries in mode 5. But I want you to know that in some questions, you'll be limited to the number of entries to work with. In some questions, you'll be limited to the number of entries to work with. Maybe they will say that, okay, use the entries 1, 3, and 4 alone. When it happens that way, you don't need to include other entries to it. So please take note. But unless maybe they ask you to draw the multiplication table or the addition table in mode 6, 7, 8, using all the entries, then for that one, you don't have a choice. You must use all the entries. Okay, so let's work out the multiplication. You know that 0 multiplying any element still gives you 0. So we can just fill in those side. So we have 0 here, 0, 0, 0, 0, and 0. So 1 also multiplying any entry still gives you the same number. So 1 multiplying 0 gives you 0 here. 1 multiplying 1, we have 1, 2, 3, and 4. Now, I think the same entries will be here. 0 multiplying any entry is still 0. So we have still zeros here. Then 1 multiplying any entry gives us the same number. So we have 2, 3, and 4. So it's only the side that the values may change in a way. Now, 2 multiplying 2, what answer do we have?
4.
We have 4. And 4 in mode 5 is the same as 4. Do you agree with that? Yeah. Then 2 multiplying 3, an answer of what? And 6 in mode
1.
5, we have 1. Good. Then 2 multiplying 4, the answer is what?
8.
8.
8.
8 in mode 5, the answer is what?
3.
3. Good.
3.
So that is what we are going to have there. 3 multiplying 2, the answer is 6. 6 in mode 5, we have 1.
1.
3 multiplying 3, the answer is 9. 9 in mode 5, the answer is what?
4.
4. Good. 3 multiplying 4, the answer is 12. 12 in mode 5, what do you expect? 2. Good. 4 multiplying 2, we have 8. 8 in mode 5,
3.
3. 4 multiplying 3 is 12. 12 in mode 5, 2.
2.
4 times 4, 16. 16 in mode 5,
1.
1.
1.
So that is the multiplication table in mode 5. Very easy as well. Multiplication table in mode 5. So in this case, you realize that multiplication table in mode 5 is closed. Likewise, addition table in mode 5 is also closed. Please, are we all okay?
Okay.
Good.
Yes.
Now, let's take it that they ask us to evaluate using the tables we have. So evaluate, let me scroll up a little so that I can get space to do the writing. So from your table, evaluate the following. Evaluate the following. So we have one question as 1 plus 2 all multiplying 2 plus 2. So we are using the tables that we have to evaluate the solution for this question. That's number one. Number two, I have it as 1 plus into bracket 2 multiplying 2. Okay, so I have just these two questions. We'll come back to tables later on with other questions. From this, I'm going to another thing. So let's assume that we are to evaluate this solution or this question using our tables here. Now, from our table, 1 plus 2, from our table, 1 plus 2 gives us what? 1 plus 2, it gives us what? 3, right?
Yeah.
So it means this bracket here, the answer is 3. And then from our table again, 2 plus 2, 2 plus 2 from our table, 2 plus 2 is 4. So from our table, 2 plus 2, so we have 4 here, we have 3 here. So in other words, final solution is 3 times 4. So you come to the multiplication side. 3 times 4. What answer are we getting from the table when you trace? 3 times 4. It gives us 2. So the answer to this question is 2. The answer is 2. Are you okay?
Yes.
Should I go over or you're okay with it from the way I traced it? It's simple, right?
Yes.
Yeah.
All right. So let's go to the next one. This is only one entry, so we don't have to temper with it. Let's work with the bracket first. 2 times 4 from our table. 2 times 2. The answer is what? 4. From the table, 2 times 2 is 4. So we have 4 there. Then we come to addition. So we have 1 plus 4. So 1 plus 4. What do we have? We have 0. So the final answer is 0. So whenever they ask you to use the tables, this is how you deal with it. Can I add one last thing to it? Okay, this time
Yes.
around, this is how the question may go. So they can ask you to find the value of n. Find the value of n. Let's take it that we have n times n is equal to, find the value of n. N times n is equal to 0. N times n is equal to 0. Do I have your attention?
Yes.
Please don't let anything mislead you. If you have problem with your background, kindly mute yourself so that we have a smooth lesson. Now, n times n is equal to 0. N times n is equal to 0. So it means such a question, we only need the multiplication table to get the answer. So we are looking for a value which when it multiplies itself, we must get 0. So from the entries that we have here, which number multiplies itself and we are getting 0?
So 0.
It is 0. So you have to give us an evidence. So you just have to write 0 multiplying 0 is equal to 0. Therefore, n is equal to 0. That is your evidence. Then again, the question could have been n plus n is equal to 0. So you have to use the addition table to find out the value of n. But before that, you give us a fair hand notice from the table. So from the table, what entries added to itself gives you 0. Look at the entries from the addition table.
0.
So you have 0. What else? Is it only 0?
3 plus 2.
So you are having 0 plus 0 giving you 0. And then you also said 3 plus what?
2.
Remember, the end value should be the same thing. When you say 3 plus 2, there's a question mark on that. So you can't use 3 plus 2 because the same entry should add
Okay.
up to itself. So it's supposed to be what?
0 plus 0.
So it's only 0 plus 0. This cannot be a possible solution. This cannot be a possible solution. So it is 0 plus 0 giving you 0. Therefore, n is equal to 0. Please, are you with me?
Yes,
Yes.
please.
All right. So please always be careful with this kind of questions. Be careful with this kind of questions. So the whole idea of addition and multiplication tables of modular arithmetic is what I've explained right now. You'll be doing some examples for me, but because of time, I'll give it to you as an assignment. So write this down as an assignment. All right, so this is one question I would like you to solve for me. So you can take a screenshot so that I'll move on to the next activity. Please, have you taken the screenshot?
Yeah.
Okay, good. We are moving forward.
Okay.
Yes, please.
You always have been given the entry.
Sometimes you'd be given the entries, other times you may not be given the entries. So when you are given the entries, you use whatever has been given to you. If you are not given the entries, then you must always remember to consider the elements in that given mode. The elements in that given mode. Please, am I clear?
Yes, please.
Okay, good.
Yes, sir.
Sir,
Yes, please.
please, in question number 2, is the one in the bracket, 1 and 5, is it multiplication or addition? I don't see
I can't get you clearly. Your line was breaking. So can you take the question again?
it. Okay. Question number 2.
Question number 2, it is 1 plus 5 in one parenthesis plus in the next parenthesis 3 multiplying 2.
Okay, thank you. I didn't see the plus. I thought it was multiplication.
No.
Thank you.
All right, you're welcome. So let's move forward. The next activity we want to consider right now is equations involving modular arithmetic. Equations. That's the next activity we want to consider. Equations involving modular arithmetic. If I'm not able to finish it today, I'll continue, God willing, in our next meeting. Now, when we consider equations involving modular arithmetic, it means you're actually looking out for the value in a given variable or in a given um, or a missing information in a given equation. So for instance, when do we have an equation? An equation is formed when two mathematical statements are linked up. So remember we learned that in modular arithmetic, if I have, let's say, 10 mod 2, it is equivalent to, yes, it's equivalent to what answer? It's equivalent to what?
0. 0 mode.
So 0
0 mode.
mod 2, good. So automatically this implies that 10 mod 2 is equal to 0 mod 2, or 10 mod 2 is equal to 0. So meaning you can change the equivalent statement to an equation directly. So automatically we have an equation here. But when we talk about equations involving modular arithmetic, this actually refers to we solving for missing information in a given equation. So for instance, as we have 10 mod 2 equal to 0 mod 2, or 10 mod 2 equal to 0, there might be the possibility that the question will be 10 mod 2 is equal to x. So you are looking for x. And therefore, what does the position of x assumes when it comes to the modular arithmetic? It assumes what? Yes, the x assumes what? In 10 mod 2, it assumes the
remainder.
Very good. So it means equations involving modular arithmetic, there is a tendency that you may be asked to find the remainder. You may be asked to find the remainder. Again, you may have probably 10 mod x is equal to 0. So at this point, the x is assuming the mode. I hope you get me. The modal value. I hope you get that. So in equations involving modular arithmetic, you may be asked to find the modal, the mode, or the modulo value. The modulo value. Then finally, x can also assume the number. So you have x mod 2 is equal to 0. X mod 2 is equal to 0. So when it comes to questions involving modular arithmetic, we have three main categories of questions you can ask when it comes to equations involving modular arithmetic. One is you may be asked to find the remainder. Two is you may be asked to find the modulo, or the mode in which the operation is being carried. And the last one is you may be asked to find the number in which the mode is being worked on in either mode 2 or the other. Any question on that, please?
No.
So the first one is this. Given that 6 times 3 is equivalent to 3 mod x, find the value of x. Hold on. 4 plus 11 is equal to, or is equivalent to 3. In what modulo system is 4 plus 11 equal to 3? Please take a screenshot so that I'll copy the questions one after the other. Then we start dealing with it before the time will be up. We have approximately 9 minutes to end the lesson. Please, have you taken the screenshot?
Yes, sir.
Okay, thank you. So let's take it one after the other. These are some of the questions involving equations in modular arithmetic. So taking the first question into consideration, Now we are being told that given that 6 times 3 is equal to 3 mod x, find the s value. Now, in other words, finding the s value, what do you think the s value is assuming? What do you think the s value we are looking for is assuming?
So the modulo value.
It's assuming the modulo value or the modulo system. So we are looking out for the modulo system in which this operation was conducted, and then we had the answer as 3. We had the answer as 3. So ideally, having 6 times 3 equal to 3 mod x, ideally 6 times 3, what answer do we have in mind for 6 times 3 alone when it comes to the normal world? 6 times 3 is what?
18.
It's 18. So it means we are having 18 is equivalent to 3 mod x. So the question now is, in which modulo system will we operate on 18 so that we'll get a remainder of 3? Can you think of it? I just want you to think of it right now, but I'll show you how to do it to get the actual answer. Yes, can you think of in which operation, in which modulo system did 18 operated on to give you a remainder of 3? Just think of it.
5.
Okay, so it means 5 is a possible solution. Is it only 5? Is it only 5, if I may ask? Is it only 5?
15.
15. Because 15 can go into 18 how many times?
1.
And there's a remainder of what?
3.
So ideally, just with your intuition, with your own understanding of the concept of modular arithmetic, you've thought it wise that the possible solution for x, we have it as, yes, what are they?
5.
5 and then what?
15.
Thank you. These are the possible solutions. Just based on your understanding, modular arithmetic is about remainder arithmetic. And from this question, we are looking out for the modulo system. And we've seen that the possible modulo system are 5 and 15. Now, this is how you can present it when you have such a situation without just thinking about it, like using your intuition so much. Even though whatever we are going to do still needs your understanding. So this is the proper way of mathematically presenting it. So having 6 multiplying, having 6 multiplying 3, which is equivalent to 3 mod x, the first stage is 6 multiplying 3 actually gives me 18. So 18 gives me 3 mod x. So what you must do, since the 3 is the remainder, subtract the remainder from the 18. Subtract the remainder from the main entry, the number. So you are going to get 18 minus 3, which gives you an answer of what?
15.
15. Now, when you get this 15, write down the factors of 15. What are the possible factors of 15? What are the possible factors of 15?
1.
We have 1,
3.
we have 3,
5.
5, and then
15.
15 itself. Very good. Then after getting your factors of these 15, then you test for possible solution. So it means all these numbers here, there are some of them which are the right solution to the question. So in the first place, if it is mode 1, is it possible that we are going to get 3 as a remainder? If it is mode 3, is it possible that we are going to get 3, mode X, or mode 3 from the operation? If it is 5, if it is 15, so you have to test. So in this case, if we are working in mode 1, now 18 divided by 1, the answer is still what? 18. So the remainder would have been what? 0. Do you agree?
Yes.
And we don't have 0 here, we have 3 here, so 1 is not a possible solution. If it was in mode 3, 18 divided by 3, what is the answer?
6.
And is there a remainder afterwards?
No.
No. So the remainder would have been 0, mode X. So it means, or mode 3. So it means that 3 is not a possible solution. But if you are working in mode 5, 18 divided by 5, we have it as what? You have it as 3, right?
Yes.
And there's a remainder of what? There's a remainder of what? 3.
3.
So it means 5 is a possible solution. Now, if you are working in mode 15, 18 divided by 15, you get 1. You get 1. And there's a remainder of 3. So therefore, 15 is also a possible solution. So that's how you test for your right solutions. So based on this, 18 divided by 5, we had an answer of 3, a remainder of 3, because 3 times 5 will give you 15, and 15 plus 3 will give us the 18. Again, 18 divided by 15, you get 1, a remainder of 3. So in other words, our possible solution for the question is 5 and then 15. Please, am I clear?
Yes, sir.
So the procedure is your main entry, subtract the remainder from it, write down the factors of the value you have, and now test for your possible solution from the factors. Main entry, subtract the remainder, write down the factors for the answer you get after subtraction, and then test for your possible solution. Please, is it clear?
Yes, sir.
Okay, let us take the second one, then we'll close for the day. Then you try your hands on the others for me. Let me take another one. Okay, so in this situation, what must we do? Yes, can someone take us through? First, we must do what? This is the same as 53 is equal to 3 mod n. Yes, what must we do first?
So you subtract.
We subtract what?
3 from
3 from
53.
So it's going to be 53 minus 3. And that gives us an answer of what?
50.
50. Then we write down the factors of 50. What are the factors of 50?
One.
You have 1,
2,
5,
25.
So now let us test. If you are working in mode 1, what will be the remainder? Meaning 53 divided by 1. The answer is still 53. So there will be a remainder of what? 0. Good. If we divide it by 2, 53 divided by 2. 2 going to 53 how many times? 2 going to 53 how many times?
26.
26 times. And there will be a remainder of what?
5,
1.
1. But remember, in our operation here, we don't have the remainder as 1. We are having the remainder as 3. So it means 1 is not a possible solution, 2 is not a possible solution. Let us come to 5. 53 divided by 5.
10.
10. A remainder of what?
3.
We have 10, a remainder of 3. So it means 5 is a possible solution here because you're having the remainder as 3. So end value can be 5. Then we come to 53 divided by 10.
5.
A remainder of what?
3.
So it means that 10 is also a possible solution. Let's come to the next. 25. So 53 divided by 25. Yes, how many times does it goes in?
2.
2. A remainder of what?
3.
3. So it means that this is also a possible solution. It's a possible solution. Now then the last one, 53 divided by 50. It goes in how many times?
1.
1. A remainder of what? 3.
3.
So this is also a possible solution. Now I didn't write the first one. 53 divided by 1. The answer is 53. Remainder of 0. This is not a possible solution. Then 53 divided by 2. We had 26. A remainder of 1. This is not a possible solution. So we've seen that we have 5, 10, 25, and 50 to be possible solutions to this question because we are looking for the modal system. But remember, they told us that the modal system lies between what? It lies between what?
1 and 10.
1 and 10 included, right? So ideally, what's your final solution? Yes, our end value must be equal to, yes, what's your final verdict?
5
And
and 10.
5 and then 10. Please, are we all okay?
Yes, sir.
All right. I believe each and every one has understood whatever has been taught. If you have any peculiar problem, you can inbox me to help you out. I'm so privileged having you on the lesson today. And if you don't have the questions, this is the question we are actually going through, and it's on finding what we call equations involving modular arithmetic. Once again, I would like you to visit my YouTube channel, Math Made Easy with PDY. Math Made Easy with PDY. It's a YouTube channel. It's also on Facebook as well as Telegram. You can just go there, watch some videos involving mathematics to enlighten you so much. Thanks so much for joining the lesson, and then have a good day. Bye bye.
You too. Bye.
Bye.